So as we've worked on our stoichiometry here, we've worked with moles and we've worked with grams. And now in this next lesson, we're going to add another unit that we're going to work with, and that is liters. Okay, so before we get into that and add that to our stoichiometry, I wanna teach you a little bit about solutions, because this is going to involve things dissolved in water, or solutions. So let's talk a little bit about solutions, how we measure solutions, and how it kind of works into our stoichiometry a little bit. Today we'll talk about solutions, and our target will be to do stoichiometry problems involving solutions. So a lot of the times when we work in a chemistry lab, we don't necessarily work with a substance that is solid in and of itself, but we work with a substance very often that's dissolved in water. For example, here I have sodium hydroxide, and here I have sodium hydroxide, right? The difference is this is just the solid sodium hydroxide, and here it is dissolved in water, right? And we in the chemistry lab are far more likely to work with it dissolved in water. Now, here's the thing. When you dissolve something in water, you can have some different concentrations of it. For example, this here is hydrochloric acid, and this here is hydrochloric acid. If I were to spill this on myself, I'd be fine. It's no problem. If I spill this on myself, I'm going to go get under the chemical shower. The difference is this is 12 times more concentrated than this one, right? Now, as we're doing our stoichiometry, that makes it important for us to understand something about concentration. That means, if I have the same amount of each of these, this one would have 12 times as much hydrochloric acid in it as this one, and then the difference is just water, right? So, we need a way to be able to determine how many moles of a substance is in a particular amount of a solution. And that's where we're going with this. So let's talk a little bit about how we measure concentration. With a solid substance, you can measure how many grams of it you have by putting it on a scale, right? But that makes less sense with something that's dissolved in water. So if I were to take a certain amount of this and put it on a scale, does that really tell me how many moles are in it? No, right? With a solid substance, it does. You can go to the periodic table, you can add up its molar mass, and you can convert those grams into moles. But it's not the same for something that's dissolved in water, because I could take equal weights of each of these, put them on the scale, get equal weights of them, and they have different numbers of moles. So it makes much more sense, since they're liquids, to measure them using a graduated cylinder, right? We can measure out a certain volume using a graduated cylinder and know how many milliliters that we have, or how many liters we have, okay? And then we have a tool, a way of talking about concentration that relates moles and liters. So I can measure liters in the lab, and then if I know something about the chemical that I'm working with, if I know its concentration, I can convert from that volume, from those liters, into moles. And the way that we talk about concentration is we use what's called molarity. Okay, molarity is how many moles are in each liter of the solution. For example, here with my concentrated hydrochloric acid, if you look closely on the bottle, you can see it says 12 molar. And what that tells me is that in each liter, there would be 12 moles. Now, this bottle is much less than a liter, so there would be less than 12 moles in the bottle. But if I had a liter of this at this concentration, I would have 12 moles of that substance. This one, if you look closely, says 1 molar, 1.0 molar. That tells me in each liter of this substance, there would be 1 mole of the hydrochloric acid. And the same on this bottle of sodium hydroxide. If you look closely, it says 0.1 molar. And what that tells me is that in each liter, there would be 0.1 moles. And this is what molarity is. Molarity is how many moles would be found in each liter. Oftentimes, you'll see molarity written with a capital M. So on all of these bottles, I believe, they actually wrote out the word molar. And molar is short for moles per liter. But oftentimes on a bottle, you'll see instead of writing out the word molar, they'll just put a capital M. So it might say 0.1 capital M. And what that tells you is the concentration. So I really wanted to show you a bottle that has the, instead of having the actual word molar on it, where they use the capital M. But, I buy all of my chemicals from the same supplier, and that supplier writes the entire word molar on there. So here is a picture that I found on the internet where you can see instead of putting the entire word molar, they just use a capital M. And this is a very common way of doing it, and you're going to see this on your assignments. So instead of actually putting the word molar, it's just going to have a capital M for you to see. Okay, let's say I want to make a solution that has a very specific concentration. Let's say I have here some potassium sulfate, and this is solid potassium sulfate. It weighs 174 grams per mole. If you can add up potassium sulfate, K2SO4 on the periodic table, it will come out to about 174. Now let's say I want to make a solution with a specific concentration. Let's say I want it to be 2 molar. I want 2 moles per liter. How much of this would I need to use? And how many liters would I need to make? That's what we're kind of working on here today. That's what we're talking about. So let's say for my experiment, I need, I don't know, maybe 1 liter, and I want it to be 2 moles per liter. How much of this do I need to add? All right, and that's kind of what we're working on. That's the kind of problems we're going to see. Let's go take a look at an example of one of these kinds of problems, and let's see how to solve it. Okay, here is an example of that kind of problem. The problem says, how many grams of sodium chloride, NaCl, are required to make 15 liters of a 2 molar solution? And this is the problem that we're trying to solve here. Okay, now, when it says how many grams, we're looking for grams. Okay, now, what we need to do is we need to set up a problem. It's going to look kind of like a stoichiometry problem. You'll notice we don't have a chemical equation because there's not a chemical reaction going on. This is just dissolving something in water. So there's no chemical equation here. But we're gonna do the problem just like a stoichiometry problem. So the first question is, how do I start the problem? What number do I start with? Now you're going to see 2 numbers in the problem. You see there it says 15 liters. And it says 2 molar, right? Now I'm going to tell you what this molarity number is kind of like the numbers that you get off of the periodic table, the molar mass, and kind of like the coefficients in the chemical equation. This is a tool that we're going to use to set up fractions later in the problem. So you're almost never going to start with a molarity. You're going to start with something else. So if you look in the problem, what you see is you see another number that's not the molarity. That's the number you want to start with. So here we're going to start with this number, 15 liters. 15 liters. And this is NaCl, it said. Okay? So that's how we're going to start. And now I need a tool. I need something where I can get liters on the bottom of a second fraction here. Okay? Now, what kinds of things do I know that involve liters? Can I get liters off of the periodic table? No, we've been working with that for a long time now, and we've never seen liters come from the periodic table. Can I get that from the chemical equation? I don't even have a chemical equation. Liters aren't a part of that. But liters are a part of something we learned today. Today we learned molarity, which is how many moles in each liter. So down here, I'm going to need a liter. When you're looking at the molarity, that's how many moles there are in 1 liter. So as I set up the fraction, I'm going to use that number of moles in one place and then 1 liter in the other place. Okay. Having liters up here, you know you're going to want that 1 liter down here. And that is NaCl. And then the problem said that the concentration we wanted was 2 molar. So up here I'm going to put 2 moles. So the concentration was 2 moles to each liter, right? The question asked me how many grams. If you look at where I am now I have how many moles. So we need a way to go from moles to grams. And we have a way to do that we've been working with for a while, and that's the molar mass from the periodic table. So let's go to the periodic table, and we will add up NaCl and see what is its molar mass. So here come the periodic table boxes. I will add it up here. Sodium should be 23, and chlorine should be about 35. So there I get about 58. So it's 58 grams and 1 mole. Clearly I'm going to want the 1 mole down here. So I have moles up there. And I'll put the 58 grams on top. Cancel that. Now the question asked me how many grams of NaCl, and now I have grams of NaCl. So we're going to go ahead and work that out, and that'll be our answer. So here we have 15 times 2 times 58, and these are all 1. So I get 1,740, and that'll be grams of NaCl. Grams of NaCl. So there's one particular type of problem we can do, where if we know how many liters we want and we know the concentration we want, we can calculate how many grams we would need to make that. Here is another type of problem you might end up seeing. This one says, how many liters of a 5 molar copper chloride solution, CuCl2, can be made from 100 grams of CuCl2? Okay, like we mentioned a minute ago, we're not going to start with the molarity. That's not a number that we start a calculation with. So we're going to start with the other number they give us there, and that was 100 grams. So let me start here. 100 grams, and that is CuCl2. Okay. Now that I have grams, I need something that's going to have grams on the bottom. I can't use the molarity right now. The molarity is how many moles per liter, and I need grams down here. Molarity doesn't have either moles or liters involved. So I need to think of something that has grams as part of it. I can't get that from the chemical equation, because number one, we don't have a chemical equation, and number two, the coefficients on the chemical equation are just the moles. So where can I find grams? I can find grams from that molar mass on the periodic table. So I'm going to go to the periodic table, and I'm going to add up CuCl2. So I'm going to add that up here. See, copper is 63, and chlorine is 35, and there's 2 of them. So this adds up to about 133 grams. Since I want grams on bottom, and then of course we're going to put 1 mole in the other place here. Okay, now notice my grams cancel. I have moles. And the question asked me to find liters. So now I have moles, and I'm trying to go to liters. Keep in mind that molarity has both moles and liters as part of it. The problem said it was 5 molar, so it's 5 moles to 1 liter. I'm going to want moles on the bottom. So let me put 5 moles, and that is CuCl2 to 1 liter. CuCl2. My moles here cancel. Now I have liters of copper chloride, and that's what the problem asked me to find. It said how many liters, and now I have how many liters. So let me go ahead and work out the problem. So now I have 100 on the top there, and on the bottom I have 133 and 5. So there I get 0.15, and that's liters of CuCl2. So there's another type of problem we can solve where if they tell us how many grams and the concentration that we want, we can figure out how many liters of solution we can make. Okay, there's one other type of problem we might be faced with, and this is one where they ask us to find the concentration. So this one, it says, what is the concentration of a 4-liter solution containing 750 grams of calcium chloride, CaCl2? Okay, and this one, this type of problem where they're going to ask you to find this concentration has a tiny trick in it at the end. So pay attention here, okay? Now what number are we going to start with? There's 2 numbers there we can start with, right? We have liters and we have grams. And I'll tell you what, let's preferably start with grams. So this is 750 grams. And this is calcium chloride, CaCl2. Now with grams, we should go to the periodic table and add up the molar mass. So I'm going to go to the periodic table and I'm going to find calcium and chlorine, and there's 2 chlorines. So calcium is about 40 and chlorine is about 35. There's 2 of them. So there I get about 110 grams I'm going to put on the bottom. And then, of course, 1 mole. So my grams cancel there. Now I have moles in the top, and you got to step back for a second here. This is where the little trick is. Molarity. They asked us for the concentration, the molarity, which is how many moles in each liter. So I'm going to want to end up with moles on the top and liters on the bottom. And I'm going to want something here that doesn't cancel out. I want moles to stay there. And I want to have liters down here. Now here's the thing. They give us another number, 4 liters, right? And I want to have liters on the bottom. So I'm going to put 4 liters right here on the bottom. Okay, and this is like a number that we started with. So what I'm going to do is I'm going to put 1 on the top. Like, you know how you put 1 on the bottom for that number you started with? I'm just going to put 1 on the top here because this is like a number that we're starting with. So now I have moles over liters, which is what molarity is. Let's work out this problem. So we have 750 divided by 110 divided by 4. And there I get about 1.7. So it's 1.7, and moles over liters is that molarity. It's molar. So I'm going to write a capital M there to tell me that that is the molarity. All right, so there's some about the molarity, the concentration. 3 different types of problems that they might ask us to be able to do. They might give us grams and ask us to find liters. They might give us liters and ask us to find grams, or they might give us both and ask us to find the concentration. So now, we've seen examples of all 3 of those kinds of problems. Next time, what we're going to do is we're going to take this idea of molarity and we're going to work it into what happens when you have chemical reactions between solutions. Right, so we're going to be able to use it in a stoichiometry problem that involves a chemical reaction. So hopefully this gets us a step closer to being able to solve stoichiometry problems involving solutions. And until next time, take it easy.